In this video, we're going to be looking at, well, we've been through all the different ways you can transform a trig function. Okay, we've got, let's do a quick summary, and I'll make that a little bit bigger. We've got A, and we know the amplitude is the A. There's no amplitude of a tangent function. We can see if A stretches the graph up along the y by a factor of A. B squishes our graph by a factor of 1 on B. Okay, that's along the x. And it changes our period as well, right? And we've got our relationships up here. The period is 360 on B for sine cosine, and for tangent it's 180 on B. Down here we can see translating by changing D, moves it up or down depending if it's positive or it's negative. And we have that line of oscillation that I like to use. I'm not sure about you. Otherwise you can just say it's every y value plus 2. Every y value, take 3.5. Tangent's the same as well, and it does not affect our x is equal to 90, x is equal to negative 90 asymptotes. We've also looked at C. It always looks way worse, I reckon, when you draw these, but we can see that if we want to shift to the right or left, then you go sine x take, for instance, 30. It moves the whole graph to the right 30 units, in this case 30 degrees. So you have your 91 value that you knew before goes to 121, and also you have 0, 1 for our cosine. This one here is getting plus 120, so it's going to the left by 120 degrees, so 0 goes to negative 120, and it keeps the same y value. In this one, we're going to be looking at two-step changes. So without further ado, let's look at two-step changes. And what is it meant by that? It literally is just saying, okay, let's change the A and the D. So let's have a look at this. Let's say it's 2 sine of x plus, let's go take 1, right? So there's quite a few ways in which you can interpret this, but if you have a graph like this and you want to find out what's A and what's D, the way I do it is this. I go, okay, well, where's it oscillating around? Okay, and you can see here that it seems to, the peak to peak, you can have a look at. The peak to peak, you've got a 1 here and a 4 here. So the total distance is 2. That means the amplitude's 2 because you're dividing it by 2. And it seems like it's oscillating around negative 1. So if I put that in, I'll change that to blue and change that to blue. So we can see here that the graph is following firstly C bad. So what order will that happen? C, there's no C. B, there's no B. A, so it's getting dilated by a factor of 2 along the y-axis. So let's have a look at our key point here. Let's have a look. There we go. 91. Okay, and let's just look at this point here. We're going to get stretched by a factor of 2 along the y, so it's going to go to 2, like that. And then it's 1's taken off it. That's our last bit for D. So it goes back to there. Let's look at another point, 0, 0. We can see it won't get affected by the doubling in the y value. It'll just stay at 0. Then you minus 1. So we can see that our key points seem to be working. Our line of oscillation normally is at y is equal to 0, and it doesn't get affected by the dilation. Y is equal to 0. C bad. This goes first. It just stays there, and then it moves down 1. And so let's look at another one here. And we've got cosine now. Let's look at, we'll keep the amplitude at 1, and let's write cosine 2x and then plus 90 degrees. Let's do something like that. So this is far more tricky when they start impacting inside the brackets rather than outside. Okay, so first thing, C bad. So that means we're going to move to the left 90 degrees first. Then we're going to halve all our values. So it's a bit of a head spin, this one, isn't it? So let's have a look. Cosine should move to the left 90 degrees and then have all the x values halved. So let's look at a key point. Well, we know cosine 0, 1. It's going to move to the left 90 degrees, so it goes to negative 91, and then it gets halved. So now it should be at negative 45, 1. And let's have a look. I might just have to label that one. There we go. And we can see there that it has indeed been translated. Now what about the period? Well, we can see here that if b is 2 and we only need to look at the b value, that it's going to be 360 degrees for cosine divided by the b value, which is 2, so it should be 180. How can we check that? Well, we can see here the blue, go up, down, and there we go. Look, we've got that value there. So it's 180. So we can see that the period is indeed 180. So this is just a combination of it. Okay. Last one is tangent, and tangent, one of my favorites to do for this is classic 2. Oh, let's go half this time, 0.5, and then go, let's go a dilation of x on 2. Okay, so you can write it like this as well, x on 2 or half x. So in this case, we've got a as a half, and we've got b as a half. Okay, so CBAD says there's no c, so ignore that. B, it's a half, so that means we're stretching our graph by a factor of 2, which is 1.5. And then we're going to times all our y values by 0.5. So let's see if that's worked. So firstly, if we're going to stretch everything by a half, we start at 0, 0, it stretches by a half, it stays at 0, 0. But I like to work in terms of asymptotes. So the 90 degrees, right, is going to get stretched out by a factor of a half. So the x value is going to times by 2. So this goes to 180. We can see that lines up really nicely. And the same for this one. Times that by 2 goes to negative 180. I've done it again. There we go. So that's worked really nicely. Now, we've got that key point there. It's completely gone. And I've actually lost my graph there. I forgot about that. That's okay. So I might actually paste that, copy, and I'll change that back to my original graph. And there we go. And what I'll do is I'll just add another graph, that same one, and we'll make it green, sure. So we can see there that our asymptotes have moved across, okay? And we can also see that our graph has sort of been squished out. Where is this x value going to go? Well, let's have a look. We've seen that it's going to be, CBAD says, 45.1 is now going to go, firstly, to 91, okay? But then the y value is going to get multiplied by 0.5. So now it's going to go to 90, 0.5. Okay, and we can see that's actually hit that point nicely there. So you just follow along, following CBAD. C, no C, B, half, so that means it goes 45 to 90, and then A, you multiply the y value by a half, and there's our new value. Okay, so this is a 2-step change. Hope you enjoyed it.